All right, welcome ladies and gents to day 12, which we're going to be covering radicals. So radicals or square roots, they need to be reduced as we start to get into quadratic formula, which will be coming up next. So in simplifying radicals, right, what we're going to do is we take a radical like this radical 18, we have to break it down further. Same thing with all these. They're not in standard form as they are, so you can't really just give a decimal. I know if you put it in your calculator, you will get a decimal, but we don't want that for precise form to be exact. That gives an estimated answer, which is not what we want. So we have to reduce these. So whether it's a smaller number like radical 18 or a bigger number like radical 128 or other numbers, as you see, we have to reduce them to different radical parts. All right, so here's what we're going to do. We're going to break it down in two different methods. I'll show you one where we can work with multiples and one where we can work with trees. So let me switch over here. All right, and here we go. So with this, just recenter here. So radical 18, so what I can do is this is the tree method. So if you look at 18, I brought it over here. So radical 18 is here. What multiplies into 18? And we want to avoid 1, so I went with 9 and 2. So if you break these down, 9 and 2, well, 2 is prime. It doesn't go down to anything else besides 2 and 1. We don't want 1, so that's boring. But 9 breaks down to 3 and 3. And it doesn't matter the numbers that you pick, but as long as you get to these final pieces, we call these prime factorizations. What we're looking for are pairs. So I see a pair of 3s, which is why I circled both of these. And there's 1 left over, 2 left. So look at the ends of the branches. And by the way, these numbers here that you've used already do not count. So it's only the very end. If they get broken down, you do not use those numbers. All right, so now 3 and 3, since there is a pair, you take one of these 3s and it goes on the outside. Since we have a leftover and no pairs, it stays on the inside. So that's how I get 3 radical 2. Pairs on the outside, singles on the inside. So that's C for number 1. All right, so do the same thing on number 2 here, which is a bigger number and a more complicated tree. And I'll show you a shortcut too. Well, we'll see if it's a shortcut. It depends on how you like these. So radical 128, starting here again. I'm looking for two numbers. A lot of times people will divide by 2, so I went by 64 and 2. It doesn't matter how you divide these up. You can pick other numbers as well. But break it down to 64 and 2. Right, 2's done, so we'll come back to that later. 64 we can break down to 8 and 8. Right, but 8 breaks down to 4 and 2. This other 8 breaks down to 4 and 2. But keep going. Right, I see those 2's in there, which are done, but the 4's break down. So 4 is 2 and 2. This other 4 is 2 and 2, and then you get your final branches of the tree. So what's really left are these 2's, these 2's, these 2's, and this 2. So let me actually go back and cross out everything that's not going to be needed. So we won't use this, won't use 64, by to the 8's, by to these 4's, we broke them down. So everything else that's left is there, and we're going to look for those pairs. Right, so as I look through the nice ones, 4 gives a 2 and 2, so that's one pair. This 4 gives another 2 and 2, so that's another pair. There's also these other 2's from previous, which were not broken down, so those count. That's another pair. And we have a leftover. And it really doesn't matter how you do the pairs. You can do these 2 as a pair, these 2 as a pair, these 2. Just circle your pairs. So we want to find out how many pairs there are, if there are any leftovers. So notice in this problem we have one pair of 2's, which I bring down, another pair of 2's, which I bring down, and a third pair of 2's. So all the numbers, all the pairs you have get multiplied together. So 2 times 2 times 2 is 8. Right? All the pairs get multiplied in front to become that number. Any leftovers like this 2, there can be multiple leftovers as well, become the inside. So radical 2 is there, which comes down to your answer. For instance, if you had a 3 left over as well, you would multiply 2 times 3. But here is just a 2, so we bring down that 2. Right, so pairs, 2, 2, 2. Right, that's your 8. Leftovers get multiplied on the inside. There's only 1, so it's just a 2. So 8 radical 2 which is choice D for this one. And there is also one other method. If you know your square roots, it's nice to try and break down radicals, bigger radicals, into smaller numbers that are perfect squares. And what I mean by that is radical 128 is the same as radical 64 times radical 2. Right? 64 times 2 is 128. But the nice part is if I know square root of 64 is 8, I can pull that right outside. No need to do all this tree stuff. So radical 64 is 8, and 2 does not reduce, so that stays inside. So we have a nice perfect square that's a square root that came out, 8, and radical 2 on the inside. So that's an easier way, I think, to get to the answer, which is D. But the trees are always good. When in doubt, I say always go for the trees, because a lot of times students forget what the perfect squares are to use this type of method. All right, so continue on and make these trees or look for perfect squares. Right, radical 150 will be a longer tree. 63, not too bad. So bigger numbers are a little bit tougher, but you can work these out as well. All right, thanks. Talk to you soon.